So thank you everyone for giving me the chance to share some outcomes of the future of the search for life, or as we called it, FOSSIL workshop. I'm Mark Neveu from the University of Maryland and NASA Goddard. Next, please. So this was a workshop that aimed to bring together engineers and scientists to think about the future of the search for life 20 years from now or more. So beyond the current span of the decadal that just came out. It took place over 2 weeks in March and April. Each day was actually a half day to accommodate different time zones. It was virtual, and it was highly participative. So there were about 100 participants. We had a lot more applicants, unfortunately, and couldn't accept everyone because the intent was to divide people up into small breakouts so each participant could make a significant contribution to the workshop. So I co-chaired it along with Richard Quinn from NASA Ames. And the workshop was also organized by Laurie Barge, Kate Kraft, Chris German, Stephanie Getty, Chris Glein, and Macarena Parra, spanning a range of institutions. And it took place under the auspices of the Network for Light Detection. We worked pretty closely with a few people from NASA headquarters, Mary Wojtek from the astrobiology program, Carolyn Mercer from the Pesto office, as well as Michael Lienhardt from the same office. And the participants were intended to have a variety of viewpoints so that we could both bring new ideas into the workshop outcomes and yet have people who are part of, I guess, the in-crowd of space missions, so to speak, to bring structure to the frame of the outcomes. So as you see on the pie charts here, the participation was about 30% students and a third mid-senior career and a third early career, about 2/3 scientists and 1/3 engineers, and then the majority of non-NASA funded people with some NASA people to keep structure. Next, please. So here's a screenshot of the participants. There were about 70 to 80 people logged in at any given time. Next, please. And again, the goal was to think beyond the state of the art. So very early in the workshop, we even had pre-meeting materials for participants to get familiarized with that presented current light detection concepts, such as Europa Lander and Enceladus Orbilander, with their types of objectives that these missions are addressing and the types of signs of life that they're aiming to search for. The idea being that the workshop focuses on what's beyond that. So we don't repeat what's already been done. What signs of life to look for and what levels of detection are needed. The goal being to engage those from outside usual NASA backgrounds and engaging engineers in science measurement development. So the goal for the engineers was to keep scientists on track so that instead of having just nuanced discussions, we come to actual numbers that people can design to. And if we don't have those numbers, to pinpoint them as knowledge gaps for future research. Next, please. Okay, because there was such a high contingent of students and such a variety of backgrounds, I suppose a secondary outcome of the workshop was to educate and inspire participants. So I mentioned briefing people up on state-of-the-art mission concepts. There were also presentations on tools being developed to frame the discussion on biosignatures, such as the Light Detection Forum. I actually have a few slides at the end of this short presentation to talk about it within the allotted time. And in particular, the knowledge base and the taxonomy of this knowledge base. There were talks, maybe especially geared toward the engineering crowd, about the potential for life at destinations based on life at Earth analogs. And for everybody, but especially the scientists, discussion of some advanced concept funded projects by NIAC, such as Titan Submarine, Enceladus Vent Explorers, distributed sensors in the ocean, etc. And the most important part was to bring everybody on board on what a science traceability matrix is. Since the STM is essentially the funnel through which the science gets infused into a mission concept, we really wanted to bring everybody on board so that engineers and scientists could meet in the middle, so to speak, and also to have concrete and kind of standardized and applicable deliverables from the workshop. Next, please. So what were those deliverables? We iterated on those with the NASA headquarters folks. And because this is a workshop by the community whose outcomes will be able to be used by the community as well, we wanted to make sure that we came up with actionable outputs and helpful to everyone. So a set of science traceability matrices, one per breakout group. I'll get into a second into what those 8 groups were. These STMs were flowed down to quantify measurement needs. So not all the way to the right where we get into instrument requirements and performance, etc. Kind of stopping halfway. So we have a rationale as to what to look for and how to measure it, but keeping the rest of the traceability open for people to think about, technologists and instrumentalists to think about implementations meeting measurement requirements set by the science. All these numbers had to be supported by written context, and that context and the numbers will be provided in a community report to help guide future research and technology development. Next, please. Okay, so halfway along the first week of the workshop, the participants were divided up into teams going to the destination environment of their choice. So as you can see, there were 2 Mars groups and 6 ocean world teams. This was sort of a compromise between, we left people the choice of where they wanted to work on based on their expertise or their interests, but we also wanted to ensure that a diversity of perspectives was still represented within each group, the same kind of diversity that we had in the overall participation. For example, each group had some engineering input, some input from non-NASA people, as well as people used to working with STMs to frame the deliverables. We considered other environments, for example, at ice giant moons or dwarf planets or even Venus, but eventually the choices kind of crystallized around this list. Next, please. Okay, so here's an example outcome at the end of the first week. I can't expect you can read all this, of course, but this is sort of a left side of a science trace matrix listing science objectives and physical parameters and observables, part of measurement requirements. Combined from all the teams, there are about 120 measurements. So the first week was really to try to kind of flesh out what can be looked for at these environments. And next, please. So given the breadth of measurements, the second week was centered on focusing the discussion onto what hasn't been done yet. So what we term understudied biosignatures. And 3 of those in particular kind of came up from that first week of work. We term those dynamic disequilibrium, catalysis, and informational polymers. Dynamic disequilibrium is kind of the idea that of measuring a number of physical and or chemical parameters at different points in space and or time, and thinking of the idea that biological systems might lead to different patterns compared to abiotic processes. Catalysis is the idea that living systems make processes happen faster than they would otherwise. And informational polymers actually have been discussed a little bit before in the context of ocean world missions. I believe the Enceladus Orbilander includes an objective to search for informational polymers, but the idea here was to get more quantitative and focus the types of measurements that could be made and the types of requirements that could be set. So we really pushed the teams hard for 2 days on coming up with specific numbers or identifying what was missing and justifying those. We also spent about a day discussing sample handling requirements as set by the scientific measurement requirements. And this covered both sample acquisition, so obtaining sample from the destination environment, as well as sample processing or preparation. And there we let the team speak a little bit about specific measurement techniques and what kind of sample would be needed to in what form the sample would be needed to be for that measurement. Next, please. Okay, so it's kind of a summary slide for the fossil workshop. So heading into the future, the workshop identified understudied measurement requirements to search for a broader set of biosignatures, moving 20+ years into the future. It aimed to strengthen the understanding and knowledge exchange between engineers and scientists to motivate future research and technology and mission developments. And there's a formal report in the works. So we're just getting started on it 2 weeks after the end of the workshop. For a few weeks, the Google Doc deliverables by the teams were left open so they could tie up some loose ends. And now we're going to start compiling the outcomes. I'll just add to finish that there were many more participants than could make it, unfortunately, because of the nature of the schedule of the workshop. Those people were enabled to follow plenary sessions early on, but because it was so participative, it was kind of hard to then involve everybody afterwards. So please, when the report comes out, hopefully it'll be peer-reviewed in astrobiology. Don't take it as gospel. This is definitely meant to seed discussion and to offer avenues for future work, but not meant to be the final word. Okay, before taking questions, I would like to quickly discuss another outcome of network for light detection work. Next, please. This is about the light detection forum that's being developed within a team called the Center for Light Detection, which is part of Enfold. Next, please. Why is that happening? Both the just newly released decadal as well as a previous report from the National Academies outlined the need for the community to develop a comprehensive framework to assess signatures of life as well as definite signs of non-life and whatever complications are associated with these signs, false positives and false negatives, and in what contexts, based on specific environments. So in response to that charge, next slide, please. The Center for Life Detection has developed a web tool called the Life Detection Forum. It is still in development, I should say. It is aimed to comprise 2 main modules. There's a knowledge base you see on the left, and then the technology forum on the right. The measurement technology forum is still under development, and it's meant to eventually be some sort of Wikipedia of the in-situ techniques and methods, as well as remote sensing. The knowledge base, though, is more advanced at this point. It's been live for over a year now. It contains information on what to look for in terms of signs of life, and content has been contributed by experts within the astrobiology community on those specific signs of life. About over 100 members now have contributed, so it's becoming quite comprehensive. Next slide, please. So delving a bit more into the knowledge base, the idea is to kind of standardize and organize and centralize information from the diverse body of astrobiology knowledge to facilitate the use of that knowledge in mission planning. In practice, what this means is that whether it's chemical information or knowledge from the organic chemists about chemical biosignatures, or geologists about morphological signatures, for example, or maybe delving more into radiative transfer considerations for people looking for signs of life in exoplanet atmospheres. The knowledge base frames the arguments for how prevalent a given sign of life can be and how strong the signal can be. And these, both in terms of biological sources and abiotic sources. And this is done with quite a detailed taxonomy that's been developed over many months with several community workshops that is meant to, again, gather the wealth of astrobiology knowledge and kind of standardize it in such a way that mission planners can use it. So why is this relevant for the OPAG community? It can be helpful to interpret past and current mission data with astrobiological significance, as well as future mission data coming out of Clipper or Uranus flagship or Dragonfly. It can inform the science requirements that are set for future astrobiology missions, kind of what was done as part of the fossil workshop. And there's also an educational component to it, whether you're a seasoned planetary scientist, but getting into astrobiology, or you're a student becoming an astrobiologist. This is a simple way to get at the heart of the current research on a particular signature quickly from the overall 30,000 foot view. Next slide, please. Okay, so you can start using the knowledge base now. Here's at the top is the link. You're welcome to browse current entries. You actually don't have to sign up, but if you do, you can participate in it. Develop your content. Content is peer reviewed. There are curators within the CLD team, as well as with outside partners that are expert in that particular area. You can also, if you're a faculty member, use the knowledge base in your classroom. Several faculties have done this before. For example, setting up a class where the students review the literature and discuss in class and eventually frame a knowledge base entry. And more generally, you're welcome to become a Network for Life Detection affiliate to learn about upcoming workshops, for example, as the Measurement Technology Forum gets developed, and mission planning activities by signing up at the Unfold website. If you have any questions on those last 5 slides, beyond what I can answer, you're welcome to email the CLD engagement coordinator, Svetlana Shkolyar. Her email is at the bottom of the slides. And with this, I will stop and take questions on both this and the fossil workshop. Thank you very much.